Hey everyone, if anybody's interested in moving on to the next layout, we are now going to do SV Conrod bushes, aka sheets number 11. And for this one, in the previous video we made this, which is the connecting rod. And the Conrod, or connecting rod, it consists of a thing that holds in its holes these two bushes. And these bushes are variations of cylinders. One is quite straightforward. It's a cylinder with a hole on the inside, aka pipe or tube. And the other one is more complicated, so let's start with the easy one. Alright, moving on. I copied the bottom things. So if you go into your model, here it is. If you haven't done it, go back to your original version. You grab them, you copy. You grab them, you move them to some place safe. So once you're here, you paste them here. So we have them here. And so what we know about this cylinder is the outer and inner diameter. And they're already here. And since we have already drawn it, we don't need to worry about that. However, this model does not specify the height. But that's okay because we know that these bushes should fit snugly inside the connecting rod, and the connecting rod we know is of a thickness of 8 millimeter. So what we do for this more simple shape is we do a copy, we move it upwards. I got F8, yep. So I already shifted to the 3D view. If you haven't done it and you're still in this normal drafting view, you switch and you get to either 3D basics or modeling. It does not matter which one you choose. You go here, you grab both, then once you've selected it, then you select the bottom right corner of your view cube. Now you got this fancy isometric view, and what we next are going to do is type in extrude. Extrude, I don't know what happened. Now we're going to extrude upward by 8, because that's the thickness of the connecting rod. Now that that's done, we have an inner and an outer shape. If you have not got the same visual style, you can choose any of these, but I personally recommend for this kind of operation, my favorite would still be the 3D hidden, because it's just more pure. You got these two things, and what we're going to do is subtract from the big one the small one. I don't think that deleting it is going to work, because if you delete, all you're left with is the original big one. What we are going to do is subtract. Type in the command subtract. Then select the bigger object, the one that stays. Then you press enter. Then you select the number 2, the inside one. The inside one is the one we want to subtract. Yes, and then you say yes again. And now, if my
calculations are correct,
you have a hole on the inside. Yay. Beautiful. So we have on the left side the bush little end. On the right side we have the bush big end, which we now are moving on to. And that one is, metaphorically speaking, an Oreo with a hole in the middle. And then there are holes on the inside, which we are going to worry about later. Starting out, we know that outer edge represents the outer parts of the Oreo, and they share both a 2.5 millimeter thickness, and they both share an 18 millimeter diameter. And on the inside, we have the creamy part, so to speak. It's 3 millimeter thick and has a 16 millimeter diameter. So that's 2 segments. And finally, we have the circle, which is on the very inside, and that one has the smallest diameter, which is a 12 diameter hole. So we're going to grab these 3 things. That's what we're going to do right now. So make sure you deselect everything, then select the 3, copy, move them to the north. As you can see, one of the 3 is a hidden line type. So go to properties, then change the lines so that all 3. What is going on? I'm clearly selecting stuff, so what's going on?
that is why you fail.
All right, so highlighting the copy of the hidden line, I'm going to turn it back into a continuous line for this. We have now 3 lines, and they all are continuous. All right, before we move on, let's double check that we have OSNAP turned on. And for OSNAP, let's make sure that we have the settings entered for center or geometric center. And this is because I am going to deconstruct temporarily this set of circles so that they are easier to manipulate individually, and then we'll put them back together before we perform the subtraction. You can see right now that it snaps to the center, and that's going to be handy when we put it back together. So let's grab all 3, and then let's click on the bottom right corner of the view cube, and that shifts the view to this isometric view again. Cool. So we have the 3 circles. The red one is the one that's the hidden line. The largest one is the outer side, and the smallest one is the hole in the middle. I like to think of this as an Oreo, and so to make this shape we have to remember the thicknesses, and so the thickness of the largest one is 2.5 typical. We already have the diameter since we've copied it from the technical plan. We grab it and we're going to perform an extrusion, command extrude, and we're going to extrude upward by a thickness of 2.5 since that's the thickness. We'll worry about the top part in a second. Next we move on to the second one. Extrude. We know that the middle part of the quote-unquote Oreo is the cream, which is 3 millimeter in thickness. Extrude, enter. Finally, lastly, we know that the hole travels through the whole thickness, and the whole thickness of this bush, just like with the other bush, corresponds to the thickness of the Conrod. The Conrod being of a thickness of 8 millimeter. So we're going to extrude it by that value of 8 upward. Bam. All right, so now we have 3 of the 4 shapes. We want to do one more thing, so we're circling back to this one now. As you can see, we only have the bottom of the Oreo, the lower bicky, and we want to now make the top side of the bicky. In order to do that, we're going to use a function which is part of the command copy, which is also found in move, and that function is displacement. And we used it in the previous video, and so what we're going to do is copy. Then we don't click anywhere, we just say displacement. Now we specify in which of the 3 dimensional positions we want to displace. And we're going to only move upward in the Z direction by the amount which corresponds to the thickness of the bicky plus the thickness of the middle cream, so as to transpose it higher, so we have enclosed the cream in between. So here we go. In order to do that, we need to first calculate the value of the height. It's just the combination of the 2 values. So 2.5 plus 3 equals the height of the top bicky. So 0, 0. So those first 2 zeros are x and y. And now we are positively affecting the position on the z-axis, and that is 5.5, because 2.5 plus 3 is 5.5. And now we have a copy that is exactly 3 millimeter above the end of the other one. And that is perfect because this one needs to fit in between.
Mate, you're a damn legend.
We're going to elevate this by that amount. The cream will now be elevated by 2.5. Again, move, just like copy, have the function displacement or argument displacement. And we know that a bicky is 2.5 thick, so the height should be 2.5. We do 0 on the x-axis, 0 on the y-axis, and now we type in 2.5 for the height of the cream. And nope, we just continue like that. Yep. So now, if everything is all in well, we are good. Excellent. Now to shift it into place, we're going to slide it into place. We have in OSNAP activated the center option. So now we line it up, but not just that, we need to make sure that the cursor itself hovers on the crosshair. And once we have the crosshair, we just drop it off like so. And now when we go back to the bottom right corner, we can see that the cream is nestled snugly in between the two bickies, making a perfect Oreo. And we're almost done for the main aspects of the shape. We have the final bit right here, and we're going to do the very same thing. We're just going to move it in place. And the easiest, once again, is to ensure that we are in the right position for that, and top is the best. If you are on front or right and you're adjusting the position and somehow you're in the wrong position, you can manually rotate this thing, but you can also safely click on the arrows at the top right, and those will allow you to rotate so as to always point north. Yep, so we grab the hole that we're going to make. We're going to perforate that Oreo, and now we are going to perform the subtraction. As you can see, it's fitting perfectly in there. We first type in the command, having deselected everything. We are going to select anything that will be subtracted from. So we take anything that's not going to be the whole. That's it. And then you press enter. Now we select what will be subtracted from it. So the hole itself, the inner 8mm thick cylinder. And you press enter and confirm once again by pressing enter. And now we have the hole. And that's how you get an Oreo with a hole in it, which is almost all we need for the bush big end. But there is more to it, as you know. Next thing we cover is the 3 holes. All right, so the Oreo has been perforated. That's gorgeous. We're moving on to the 3 holes. For the 3 holes, my personal recommendation at this point would be to select all the hidden lines and maybe even the center lines. I think the center lines are maybe optional, but it'd be worth grabbing the stuff that's already in the technical drawing because it saves us time. Even this, well, we need maybe this, yeah. But yeah, so that way we have the 120-degree angle intervals, and so that could help us ensure that things are oriented and moved appropriately in the 3D version. So at this point I'm still in the 3D view and I am moving this upward, and I'm going to make it collide with this so that we place it dead on in the center, and I press escape. It looks like some things have been pasted and it looks like some things have not, but fear not. Really what you're looking at right now is something where some things are hidden and some things are not hidden. And in order to see everything in the drawing, we just need to switch back to the 2D wireframe so that everything is transparent. If we select it, we can see that they are in fact placed at the bottom. So now that we're here, we have now kind of convenient reference lines for where to place the cylinders. So we know that they're 1.5 in diameter, the holes. We have the view in wireframe, and we are still in 3D view in terms of the model view. And we're going to switch back to a model view that is 2D based, drafting and annotation, like in class. We're back in 2D so as to make the circle. The circle that is then extruded in order to make the cylinder holes. And we're going to use the function circle, and we know it's 1.5 in diameter, so we click anywhere, but maybe we just use existing lines for reference. And I'm going to say D for diameter. Now, is it in diameter? Let's see, 1.5. That looks about right. I think that my hidden lines are too wide to represent 1.5. I will do a little dimension to double check. Do I in fact have here no, it's 2. I'm gonna check my dim style, see if my units are too simplified. Yeah. All right, we're gonna add 1 decimal. So now when I measure, hopefully it should measure 1.5. Excellent. So we know we have a 1.5 here. Clearly these holes, the hidden lines, are inaccurate. So we might as well delete these hidden lines, because they're just going to confuse us, in my case. You might have drafted this appropriately. I clearly have not. So we grab the cylinder, extrude. It's really just 16 minus 18, so 4.
Fool of a took. Throw yourself in next time and rid us of your stupidity.
Alright, so it's longer than it probably needs to be, but at least it will be safe. We're going to move it up, then rotate it, then insert it. So this will result in move, rotate, move. To do that, first we need to determine by how much we lift it up in the air, and that value will be if we know that the lower thickness is 2.5 and the middle is 3, and we want it to be at the middle of this 3, so that's 1.5. So we do 2.5 plus 1.5, which is 4. We're going to elevate it by that much. So we take this, we say move, specify base point, let's say the bottom, and then we're going to do displacement, and we're going to do 0, 0, 4. It is now located at that height. Okay, so the base of the cylinder matches the middle of the entire thickness, which is good, because the next thing we're going to do is rotate it so that it will insert into the cream. So what we're going to do next is the command 3D rotate. We're going to specify the base point of the rotation. So instead of having the gizmo here at the middle of the thing, we're going to place it at the bottom, which has now been lifted up. And by placing it here, it is now the axis upon which the rotation will occur. So the bottom is the axis. And now that we have selected that, we pick a rotation axis, and we want to rotate it on the green, aka Y axis. So quick click. And now you just specify the angle of rotation, so you type 90. And now it toppled over. Let's verify if its height matches. It looks pretty good. Excellent. So now what we're going to do is insert it. Let's stick to this view for now. What we want is for this to penetrate by 4 millimeters the thickness. And so we'll have the cylinder, we'll ensure that the cylinder sticks out on both sides of this cream. So we do move, and let's pick wherever, just maybe in the middle. Ensure that you have activated F8 for orthogonal, so that when you slide it, it doesn't go everywhere like this. We want to lock it in that x-axis as we insert it. Alright, so we have now inserted it. As you can see, it sticks out on both of the two sides. That's what we want. Now it's here. Let's grab the whole thing. Then go back to the top front right view. Alright. Now to verify if it is inserted properly, we can switch to a more cosmetic view. Good on this side. Let's verify the other side. Top front left. And it sticks out on that side. Excellent. Going back to that view that I stick to. We're going to perform subtraction of this over this. So when we do that, we first select what we want to subtract from, so the big shape, and then from that we remove the cylinder. Now if we do this right now, it's good, but then we're missing an opportunity to then create the 3 instances, because now that the cylinder has been used to hollow out, we don't have a cylinder to then do the 2 other ones. So let's go back. We have the cylinder. Let's not, as of yet, subtract it. Let's first duplicate it and rotate it. So what we're going to do is grab the whole thing first, rotate the view to face top down for an easier viewing experience. We're now going to select the cylinder that exists. Then we're going to use this new nifty command that I've discovered, array polar. I love it. So what we want to do next is specify the place where the three cylinders converge. And to do that, ensure once again that your OSNAP is activated. So you click it. Now don't panic. I know it's creating more cylinders than we want. We're going to use this argument called items. And for items, we're going to specify not 6, as you can see. So I type in items and now it says 6. We replace it by 3. And now, look what's happening. We now have the 3 cylinders placed exactly where they need to be placed along the 360 degrees. And to verify, we grab the stuff and change views again. Now the 3 are placed indeed where we want them. And they are also all 3 on the correct height. So now that we have the 3 cylinders, we might think that we're good to start subtracting them from the overall shape, until I discovered that if you try to do that, you grab those 3. Well, let's try just for the experiment. Subtract from the big shape the 3 small ones. All right, so you expect to get 3 holes, and what happens is that it considers no solid surfaces or regions to be selected. And that is because AutoCAD does not like doing subtractions using arrays. So what we're going to do is grab the 3 cylinders and first explode. So you type in explode or ex for explode, which will cause the 3 cylinders to be considered as 3 individual solids. Alright, so deselect everything. Now we can try subtract, grab the Oreo, press enter, select the 3 cylinders, and now if I press enter, we have the 3 holes in the cream of the Oreo, exactly where we want them. I'm gonna switch to 3D wireframe. Yep, you can see the view. Alright, next thing you want to do is clean up the project. I have behind the scenes already removed the dimensioning, but for the video I am just drawing some stupid lines so we can then show that there's stuff that we don't want to represent for the 3D isometric view when we are setting things up in the layout of the Conrod bush page. So let's clean this up. We shift this out of the way on the X or Y axis, but ideally you would use the X. You grab the stuff that you don't want, aka annotations, dimensioning, etc. Delete it. Potentially bring this back where it used to be. Then let's think about how we want to set things up in the layout. I am going to go back to my old version. I used to set all my models inside the same viewport as the one used for the blueprint. As you can see, there's one blue frame surrounding the stuff. And it works, and it's maybe good enough for some cases, but let's try to be a bit more professional and separate things. So for this new instance, assuming that your blueprint so far looks something like this, you've already set up your layout, you've set it to 421, you've locked it, so that's good. But now we're going to unlock it, right? So click the padlock so it's grayed out, and then you reduce the size of the viewport so that we can then create 3 viewports in the top. So we're going to have one that's going to be angled this way, one facing straight, and this one will be facing the other way. And so we'll have the camera set up in a dedicated fashion for each. Now let's be lazy and grab something we've done in the previous video, which is the viewport for the connecting rod as we've made it before. So you copy paste it by doing Control-C or copy clip. Then you head on over to the new layout of Conrod bushes and you paste it. You specify the insertion point. You grab onto the viewport borders, play around, see so it looks nice. So in that version, or the first layout, we want to have the Conrod in an isometric view. But in this new version, the Conrod is meant to face head-on. And the way we're going to do it is to just readjust the viewport for this one. So, right, by double clicking, we've activated this viewport. Yep. All right, so before I do this, unselect, zoom in. All right, so you should be able to see this view cube here. As you might remember, we've set it to top, front, right. And instead of having this isometric view, we're going for the front-facing one, which should result in... Oh, I made a mistake.
No, 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 no.
First select the model, then change to the front-facing. Now, if I deselect, unzoom, look at this beauty. It's facing straight. It's perfectly set up. And now we're going to create two new viewports for the two other views, which are the bush little end and the bush big end. So here we go. We ensure that we are again in drafting annotation. We have selected the layout. We're in layout mode in the ribbon on the top. And then we click on rectangular. There are also other shapes we can make for viewports, which is very interesting. But for now, we're selecting rectangular, and we're going to draw a new viewport from scratch. As you can see, this viewport is completely zoomed out, and we need to find what is our source of interest. In our case, on the left side, we want to have the bush little end. So once you've found it, you can, let me first zoom in a bit to make it a bit more easy to see. All right, make sure you got your view selected. Yep. And then we're going to set up the front. Select the model, set it to top view, and then we're going to rotate it in the model view. So we go back in the model view, and then now we do 3D rotate, and we're going to rotate it along the green Y axis. So for that, let's sure we're in a isometric view, top, front, right. We grab the model, we say 3D rotate, and then click anywhere on the green ring, and then type -45, I think. Let me see. Yeah, that's it. -45 to angle it towards the Conrod in the viewport. So when we go back to the Conrod bush, it's looking good. And now we're going to deselect this, move on over to this side, and create another viewport. But we could just copy paste this one. So let's just do that. Control C, or even better, CO, specify base point, and shift it to the other side. You might want to resize it a bit. Let's avoid overlaps. There's not much point in displaying twice the same model, so let's, in the viewport, once you've double clicked it, pan to the right. So you can type in pan, or you can hold down the mouse button and go over to the other side. And this, as you can see, is clearly the other model with the 3 holes at 120-degree intervals. So now we're going to go back in the model and perform a rotation in the opposite way. So 3D rotate, again identify the axis, which is the green Y axis once again, and we're going to rotate it by 45, not -45 but 45. So yep, I believe rotations are performed on an anti-clockwise basis by default. So now we go back to the layout, and we have our 3 views. I might just do some minor adjusting here, and I think this is pretty good. I am thinking of actually connecting items between the different viewports. Thing is, right now they're all deselected, so if I do this, I draw a line from the inside of this hole to the outer diameter of this object, and I do the same on the other side here. This, by the way, potentially is considered sacrilegious. Interacting with a viewport in such a way is maybe not the way some people might do this, but I am not playing by the books. And here we go. So this looks like it could evoke a sense of like, oh, this is the exploded view. But the idea is that you imply that the bush on the left goes in the hole on the left, the bush on the right goes in the hole on the right. And this version of the model, the old one, actually has the same items inserted in there. Now I completely winged that when I did it, and The truth is that they're not even lined up properly inside. But it's going to be easier now because everything is at least on a 90 degree or 45 degree orientation. Going back in the model, we're going to grab these two and do CO for copy. I'm going to grab a specific point for reference and then move them over here. Now, this is a bit madness.
This is madness! This is...
AutoCAD.
We had rotated this at -45, so now we're going to invert it back to 45. So now it's facing upward once again, as it used to. 3D rotate. Similarly, this one on the opposite was 45, so now we're going to do -45. Back to facing upward, and then we're going to try to fit these in there. So this one, we're going to now rotate on the x-axis, the red one. So we're going to click once, and then on the red circle, and then you press 90 degrees. And now it's rotated this way. And this one, same thing. Click on the red line, rotate 90 degrees. So now they're both oriented in ways that can allow them to be fit inside the model. Now remember, this Conrod is shared between two different layouts. One that is not meant to have these inside because it's the original step, but this is the second step, and in this one we want to fit these guys inside these holes. So what we're going to have to do is, before we plot this, we're going to have to hide these. We're grabbing these three things, we switch to the front view, and then we slide it in place. First on the X position. Now, can I get it to fit perfectly? I think this is pretty good. It's not snapping in position because OS-snap clearly is not activated. So let's do it again. Double check that your OS-snap is activated here so that things snap correctly. We've got the three things here once again. All right, back to front. If all goes well, move it in place using the appropriate move command from the center of this one to the center of this one. Excellent. Now we do the same on this side. We grab this one, we say move. You really got to use the commands, because if you just try to do it with a manual way, you lose some power.
AutoCAD.
Come on, where? There we go. All right, so now it looks like they're fitted together, but of course we are... What? Oh, well, it seems that it's in place. All right. Well, I guess I did it the proper way first time around. This is beautiful. Okay, so now let's go back to the connecting rod, this one, and believe it or not, it's perfect. This is the old one, this is the new one. I think we can all agree that this one is just a little more proper. Alright, so you might notice that these things exist on paper, but they don't exist in real life. So that's why they can cross the boundaries of different viewports, allowing us to create different views on different viewports while having lines that overreach. And with that, we are done. When you want to plot this like this, remember that if you followed everything so far, this is not supposed to, these two bush are not supposed to be fitted in this first view. So if you're going to do this, when you're plotting this one, I would recommend actually selecting these two and doing hide. One more time. Hide objects. Right. So now we're left with the bare bones of the first step. But of course, once you get to this stage, you want to show these things inside. And then what you do is you undo that by saying unhide, unisolate objects. So depending on the steps, you can hide and unhide while reusing the same objects. As you might have noticed, the connecting rod has a blue border, whereas the two other ones have black borders. And so that's because we created the two outer ones and we copy pasted the middle one using a viewport that is of a lavender color, and that is the one that comes with a template. So this layer we're going to copy as a property onto these two outer ones. So for that we just match property, grab the original, click, press on the two other ones, and now you can see that their colors turn to blue. Once you're done, you press enter. That's it. Now when we plot, they will not show up on the layout. So that's it.
This is going straight to the pool room.
With that, I think we're done for sheet 11, and I hope this helps. I hope you've been able to follow along, and if you've got any questions, let me know. I'm learning as we go as well, so yeah, hope you liked it, and see you in class.